is still a dominant research area in science education. You will see in few minutes in my analysis. And also the science teacher education, science learning in museums and other informal settings. It is also an emerging area in the last 30 years or so. Children's ideas, misconception, those kind of topics as well. Quantitative measure of student performances, educational psychologies become quite visible. Educational psychology is here, 1970s, 1980s. There were a lot of work on this. And also quantitative methods, assessment and student interest in motivation after 1980s again. Cognitive models and representations, argumentation and scientific practices. You can see how fast it is improved after the 1990s, after year 2000. And also gender, race, and then the STEM pipeline. And STEM pipeline studies are going back to at the beginning of the science education research, actually, but it is becoming quite popular recently. And also the identities and the discourse analysis. They also did a very nice visualization about all these three broad areas. You can see that at the beginning, the first area on the left-hand corner here, you can see the science, the first topic, science content topics. These areas were very popular at the beginning, and then it is getting less and less and less after the years. And then the teaching focused topics are still a large area of the science education research. And also the student focused topics are also getting quite popular in recent years, but it is dominating the almost whole research area. So basically two main areas, teacher-related research and then student-related research are dominating the science education. But these are, be reminded that these are for only science education, the journal called Science Education, the papers published on these journals. So these graphs are giving some analysis for the rest of some of the topics. I would like to just show you some of the trending areas, like science in everyday life is getting weak. And then the science teacher preparation were very strong at the beginning, but getting weak now. But if you look here, these two ones, the black one, argumentation and science practices, is getting more attention in recent years. Also the identities and the discourse analysis also getting more attention in recent years. There are also other trend analysis studies in the literature available in the science education, which I mentioned at the beginning. Cemal Tosun, my colleague, he was my colleague our colleague at the beginning, but now in a different university. He analyzed more than 13,000 papers published in science education area in different journals, indexed in the Web of Science. He found out that the recent topics are science education, STEM education, nature of science, assessment, professional development, science, scientific literacy, argumentation, gender, and conceptual change were the dominant research areas. And also, there's another trend analysis, which is only analyzed around 6,000 papers in SSCI journals. They also found out the similar results, like conceptual issues in science education, gender, scientific argumentation, professional development, science learning, evolution, and peer review. Those kind of studies are quite popular. With this, I would like to just give a short information about how Turkey involved in the science education. Turkey actually involved in science education after 1990s. Before 1990s, there were no proper research in Turkey in terms of science education. In 1990s, there was a project called Higher Education Council and World Bank supported National Education Development Project. Part of this project, there was a discipline-based educational research are encouraged, and also there was a structural reform in the schools of education, college of educations, and also a lot of scholarships were provided for those people to go abroad and study science education, which I am one of those recipients of those scholarships too as well. Also in 1994, we started the biennial National Science and Mathematics Education Conference, which has this year we are going to organize in end of September, I think the 15th of the National Science and Mathematics Education Conference. And also just next week, we are going to organize National Chemistry Education Conference in Istanbul. I think it will be the 9th one. So the research in this area are developing. So when it comes to the bibliometric analysis is just kind of a statistical methods. They use the statistics to do some kind of trends in the bibliometric data, which is provided by the databases like Web of Science, Scopus, or those other databases. So it's a kind of quantitative analysis based on the statistics and based on the number of documentation, citations, authors, those kind of things. Who is doing what kind of research is done, what are the main areas of research, or those kind of things. It helps to uncover the emerging trends in the area and also the collaboration patterns, which countries, which authors, which journals are collaborating with each other in terms of citations or those kind of working together, and also explores intellectual structure of a specific domain in the literature, also maps, visualize the results that you can understand easily and then you can see. But we have to be careful about evaluating the results of bibliometric analysis. This is quite important because we rely on the data which is provided by the databases. Databases sometimes provide missing data as well. There are a lot of missing data in the data. We get data from the databases also. And also those analyses are based on the citations, those kind of some of the quantitative criteria. So it is not everything, but it provides quite good indicators to see the main area. So if you do a bibliometric analysis, so you can just stop and then look for the whole area, what's going on. Because time to time, we scientists, we researchers delve into a research area and then forget what's happening out of our research area. So it provides you a chance to go into, to look to the whole broad research area, and then you can also identify where the gaps are available. So if you are a new researcher looking for a topic to study, I would recommend you to learn a bibliometric analysis and do some bibliometric analysis in your area to choose your research topic. Also, you can see what are the novel areas, which areas are emerging and which areas are dominating the research area, those kind of studies. So I would like to share my results with you. In my study, what I have done, I have downloaded data from the Web of Science in the science education. I will give in a minute how I did the research. In the last 22 years, including the year 2000 and year 2022 as well. So it covers 23 years altogether. The data comes from the Web of Science, and I use the WOS viewer and then the bibliometrics for the analysis. So in this analysis, you can see the main trends, emerging areas, overall picture of the research in science education. And then you can, if you are a young researcher, you can see what are the research gaps and which countries are getting attention in this area and then which countries are dominating the research area, those kind of things. And you can see the contribution. And I will give also a brief information about the Türkiye's contribution to the science education research. I just used science and education terms to the search under the topic in the Web of Science and limited with the year 2000 and 2020. And I limited the search with the articles and the reviews, not other papers. And also I used this limitation, I'm not sure whether you can see from a distance or not. I'm sorry for this one, but this is a screenshot from the Web of Science. I also limited with SSCI and the SCI expanded. So not the other databases. As you know that Web of Science has several other sub-indexes. But I include on the Social Science Citation Index and Science Citation Index expanded. And also I limited with the educational research. And the topics is education, educational research, or education scientific disciplines. So I limited with this. And at the end of this limitation, I get 14,680 papers. So all the bibliometric analysis that I have done, and then I'm going to give a presentation now, based on these papers, articles and reviews, including the year 2020 until including 22, and also Social Science Citation Index, Science Citation Index expanded. If you don't know about WOSFever, it is a very simple software that you can just learn easily. There are a lot of tutorials available on YouTube and also very nice guide for how to use it. You can just download it from the web. It is free. You can use it. Anybody can use it, but be aware about the limitations because there are some limitations on this one too as well. There are screens like this that on the web WOSFever you can do analysis like co-authorship analysis, co-occurrence analysis, citation analysis, bibliometric coupling, co-citation analysis based on the author's organization or the countries. So these are some of the screenshots that you can get familiar with the software. And I also used RStudio Bibliometrics because one of the positive sides of the RStudio Bibliometrics, you can get the data in Excel format. You can work on the data and then you can download the data in Excel format. You can do extra analysis on those data because they have some kind of certain analysis that you can not go beyond this. So I used RStudio to get this data in Excel format as well. And I did my own analysis too as well, separate from their visualization. In total, as I said, we have more than 14,000 papers, including Turkey's contribution is around 1,000 papers to this. And then I grouped them into 5 years period in the different groups. You can see here that the number of papers published in science education in Web of Science index journals start to increase from 2008. What happened here, as you may remember, Scopus Elsevier group has put the Scopus in practice in 2004, and then Web of Science, as a response to this one, get a policy of expanding, getting more journals covering more journals in the Web of Science. And now, due to this, number of papers started to increase here. And then it reached a peak in 2020. After 2020, there's a decline in science education papers. We see that this is a main effect of the COVID. So during COVID time, science education research is really badly affected because majority of the science education or the educational research are done with the people in the classroom, in the school. So if the schools are closed, then it was really difficult to collect data, and then the number of papers are also declined. In this graph, I would like to show how Turkey contributing to the science education community. The first blue line is showing the number of papers published by the Turkish authors, and the other one is the total number of papers. And then the gray columns here, you can see the right-hand side, it's showing the percentage of the Turkish authors' papers in the total number of papers. So you can see that Turkey has get into the science education area is very fast. After 2005, 2006. So we contributed quite a lot to the science education community. And it reached to a peak in 2012. And then it started to going down again. So there was some zigzags. And then again, the number of papers in recent years started to increase again. to contribution of the Turkey is quite changeable, but it's significant here. In terms of what kind of keywords the authors are using in their papers, I have done two different analyses. The first one included the science education here. You can see if you are quite a far distance, I'm terribly sorry for you, because these are the screenshots that I have received from the VOS viewer. I cannot do anything else for those things. And at the beginning, I included the science education. The term science education is dominating the whole map. And then you cannot see anything else behind the science education. So I decided to remove the terms science education, science and education. I particularly searched these terms, so I removed them. And then I analyzed the rest of the keywords. So these are the main key terms here. So you can see here, there are a couple of clusters here. There's a 7 cluster. Group of people are doing teacher education research. There's a group of studies here. I think many of us are not aware of those kind of studies. I didn't look into the detail who is doing this research, but there's a group of research which is called educational economics. I'm not so aware to this area, but there's a group of people are doing these research in science education. And also there's a group of studies here which is quite apart from the rest of the studies here. They are focusing on teaching strategies, pedagogical approaches, those kind of terms, and also secondary education, professional development. Here you can see the teacher education and the professional development always side by side, because they are quite related with each other. And also between 2005 and 2009, the network is becoming crowded. There are a lot of new topics, and then the 8 clusters. Still scientific literacy assessment, and here you can see secondary school science, science teacher education. They are a group. And secondary education, there's a group of studies here. They are separated from the rest of the other groups. Majority of them are connected to each other, but it's weakly connected, this group. And then the curriculum studies up there. They are weakly connected to each other. And when it comes to the year 2010, and there's a distinct 2 groups of studies. I think this is caused by the Journal of Chemical Education. The right-hand side here is mostly caused by the Journal of Chemical Education, because as you may know, Journal of Chemical Education is using some of the key words, enforcing people to use some certain keywords. So people has to use these keywords. That is why they always come together. So this group of studies are mostly related with the chemistry education studies published in the Journal of Chemical Education. So still here you can see teacher education, professional development is quite dominant area, and science teacher education program here. But on the top you can see scientific literacy here. On this corner here, you can see the scientific literacy. Studies are becoming visible. So it's the number of the papers are increasing. When it comes to the last part of the 2015 to 2019, the trend is still going the same way. Journal of Chemical Education studies are on the right-hand side, because you can see here chemical education research, first year undergraduate, second year undergraduate, those kind of keywords. And also there's a curriculum studies here in between them. And also here you can see there's a new term, which is we started to hear in the last few years on the conferences. I see Seamus here. Yesterday he was talking about systems thinking. So the people are started talking about systems thinking, and systems thinking is become visible between 2015 and 2019, and it's still an emerging area of research you will see later on. I just focused a little bit of this area so you can see more keywords like motivation here, higher education, and you can see STEM, gender, STEM education as well. so you can see also the STEM here in this area. So STEM studies are becoming visible too as well. On the right-hand side, it is the general topics of the Journal of Chemical Education. The last 3 years part, 22 to 22, this is the COVID period. In the COVID period, the studies are mostly focusing on higher education, teacher education, STEM education, and curriculum studies, professional development, teacher education, those kind of studies. And also here, there's another group of studies here. You can see medical education. This is, do not forget, this is a COVID period. So the medical education studies are increasing in the COVID period. So there are studies that published in this area too. So these are the network visualizations. And I would like to show you different kind of visualization in terms of the keywords. These visualizations are showing the whole period from year 2000 to 22, including. These are the main areas of research here. You can see on top, teaching, learning strategies. There's a group of studies here, teaching, learning strategies, and interactive learning studies, and also elementary education studies here, and secondary education here, higher education here, professional development here, teacher education here, gender and other studies too, as well here. So in detail, you can see the detail that here is also medical education studies and gross anatomy education studies are quite dominating the science education area. So the main topics here, the professional development, teacher education, and higher education, STEM education, you can see here there are two terms basically used, STEM and the STEM education. Unfortunately, in the WOS viewer, to be able to see them together, you have to work on the raw data. So it is really difficult to work on a text file. So I didn't do any analysis here, but I did later on this analysis. I brought them together so you can see how they are dominating the research area in STEM education. I'm sorry. I think I have broken the remote. Sorry, it's working. So I have done a different analysis. This is an overlay visualization. On this visualization, you can see different trends. On the bottom corner here, you can see the years. So if it becomes a yellow, that means that it is a trending area. It becomes a dark, so it is those kind of studies are published in the past. So I focused on the yellow areas, which are the areas that is coming out in the recent years. The main area is here, data science. You can see one of the keyword is data science. The second one is computational thinking. In the recent years that we see those papers, studies are in the area. So the online learning, we all expect these kind of things. And also we see the STEM, yeah. We see STEM education, we see anatomy education, and also programming and STEM together, and curriculum studies are also quite popular in this area. But computer-based education and computational thinking is popular, and also analysis on the basis on the technology mostly. These are the technological studies, quite popular, internet, web-based learning, those kind of things. And in this graph, I have done this graph with the bibliometrics, RStudio. You can see the trends, how it is changing. Here, there are teacher education, secondary education, conceptual change studies are dominating the field in the year 2000. And then it become to change like secondary education, first year undergraduate, general curriculum, higher education. And you see here, nature of science is becoming evident to the year 2010, and then between the 10 and the 15. And then it becomes here, you see the STEM education is dominating the area. In this graph, I combined them, STEM and then the STEM education together. So the STEM education, how large STEM education you can see, it's one of the main study area of the science education papers in the recent years is the STEM education, but the professional development is still a dominant area. And then in the last part, you can see the nature of science, curriculum, professional development, STEM education, secondary education, and you can see here the COVID studies. Because this is the COVID period, so you can see the COVID studies are also started to appear here. I did a different analysis for the words. The STEM education, higher education, and the professional development are the top three keywords in terms of emerging trends. Computational thinking, computer science education is also another one. And also systematic reviews and then the online learning is another area that emerging in terms of the keywords in the science education. So the common topics are STEM education. Those STEM education are dominating the area together with higher education, teacher education, professional development, curriculum, nature of science and assessment. But in recent years, we see COVID, computational thinking, data science, online learning, web-based learning, communication, writing, those kind of things. Yeah, I'm going to finish soon. So the Turkish authors analysis, Turkish authors are mostly, I would just skip this part and then come to the, just the summary part for the Turkish authors, what we do. Turkish authors separated from the rest of the world in terms of dominating research studies. Like we do STEM education, yes. We do teacher education and pre-service science teachers, but we do also chemistry education quite a lot, physics education, nature of science, argumentation and attitude studies. But in terms of the trends, we are quite familiar with the rest of the world. With the countries, it is expected that the United States is always dominating the whole science education research area. I will just give you a different graph here, but I should say these countries. There are some new countries that coming into the science education. China and Chile and Saudi Arabia, Iran, and also Indonesia is coming into the science education research area. So these are the countries that most produced science education papers. You can see that in the top three, USA, England, and Türkiye, we are in the top three. But in terms of the getting citation, the impact of the papers, Türkiye is coming to the last among the top 20 countries. So we produce a lot of paper in science education, but we come into the last. But in terms of the citation, although the United States is very high in terms of the number of papers published, Belgium, Israel, Scotland, and England and Netherlands, the authors from those countries, their papers are getting more citations. And the organization, there's the three groups of studies. The first one is something like mixture of the world. You can see here the red cloud here. And then the green cloud here is the United States universities. And among them, there are some other universities. They are also collaborating with each other and then some other countries. So basically, the authors from United States, the organization universities from United States are working together very closely. And then the rest of the world is working together with each other and then the US universities too as well. And in recent years, some of the universities are taking, and also the journals, you can see that the International Journal of Science Education, Journal of Research in Science Teaching is quite large journals publishing a lot of papers, but the trending journals in terms of citations, Cultural Studies of Science Education and Journal of Chemical Education, also Science and Education is getting more attention. I have done a different analysis based on the Excel data that I have downloaded from the web. Highly productive top 20 journals are International Journal of Science Education, Journal of Research in Science Teaching, Research in Science Education, Journal of Chemical Education. All these journals are science education journals. But when it comes to the citation, their citations are well behind the main journals like review journals and also the theoretical journals like Review of Educational Research, Educational Researcher, and Learning and Instruction, American Educational Research Journal, and Computer and Education Journal. So these journals are cited much more than the science education journals. So the science education journals are publishing quite a lot of papers, but when it comes to the citation, it is very low. And then I'm going to, because Ingo is forcing me to finish with this one, I will skip this part because this is very much discussed area. So I would like to skip that one and then summarize with its one. Science education is a proper discipline right now. And then we have a lot of papers are publishing systematic. There's a systematic increase in terms of the number of papers published, but the COVID has dropped our speed. So we are going down. United States is contributing to 40% of the science education research literature. And then the rest of the 30% is coming from Europe, and then the rest of the 30% is coming from the rest of the world. I think here we have some task to consider about this one, how we can extend the science education to the rest of the world. And the United States and then the Europe is dominating 70% of the science education research, and then the rest of the world is only producing the 30% of the science education. If we take out some of the countries like Israel and Türkiye and other countries, from this percent, it is going very much down. So we have to do some kind of consideration on this one. I mean, as a science education community, we have to consider about how we can include other countries into the science education research community. So these trends is quite popular. I will switch this one. I will say only one thing about the Turkey's contribution to the science education. Turkey has following a policy of publish or perish. For all kind of academic advancement, even defending your thesis now in Turkey, you have to publish papers from your thesis, your studies in refereed journals and also the index journals. So this resulted with high number of papers produced, but when it comes to the citations, we don't get enough citations because people don't care about the citations of the paper. They just care about the papers getting published in the journal. So there are some of the journal editors among this, these audiences here. You can see that you get a lot of papers submitted to the journals coming from the Turkey. Time to time, there are complaints about those kind of things. So we have to consider about the quality, not just the quantity. So the cited papers are different. Like we have to look in detail what kind of papers that they produce. The Dutch authors, Israeli authors, and Belgian authors, English and Scottish authors in science education, that they get more citation than the other studies. Yeah. So I will skip this part and then I will finish with these limitations. Be aware that this is only based on the Web of Science data. So this doesn't cover the whole science education area. There are also journals in the Scopus covered in the Scopus. Bibliometric analysis has limitations with some of the missing data and those kind of things. And then you have to be careful about using these results because also the citations are misleading time to time because there are different kind of policies that journals are following. For instance, in recent years, to increase the impact of the journal, journals are getting some of your papers published as a preprint and then keep your paper as much as possible in preprint form that people can read and start citing your paper. When they get issued this paper, and then they say in the first 2 years, this paper get this much of attention, but actually it is actually get more time because it is published before then. So there are some kind of tricks in this area. So you have to be careful about analyzing these things too as well. So take home messages. You can invest yourself to improve your skills in big data and then the data analysis and visualization skills because these are becoming quite easy on these days. And then do not rely on just the bibliometric analysis, carry out also content analysis, systematic reviews to see the detail, the quality, rather than the quantity. And also the images that I have shown here, it's a static, but normally in the software you can play around it. So you can delve into, you can zoom in, and then you can see more details. So for your area, please play around as much as possible that you can see what is going on in your area of research, and also learn how these bibliometric analysis are working. And I would like to finish this thanking you for your consideration, and I would like to extend my invitation for the ICC ECRIS conference, which is going to be in 2026 in Erzurum, in my university. It is an IUPAC conference, ICC, and the ECRIS is the European Chemical Society's Division of Chemical Education Conference, and it is going to be organized jointly in July 13 to 17. And I would like to thank the ESERA board for the kind invitation for this plenary talk and the generous support by the ESERA 2023 organizing committee. And I would like to particularly thank for Dilek Teke, which is my former PhD student. She helped me quite a lot on this analysis, on this technology. And I would like to finish thanking you for your attention.
Thank you, Mustafa, for this interesting talk. And you skipped a lot of slides, so we saw there's a lot of more things behind. And you sent me some of your slides last year, so I had a bit more look. Time is out now, but I think we should take 5 minutes for a few questions, if there are any. There's one over there.
I know that it is very difficult to wait for lunch here. So if you have questions.
Where's the microphone for the audience?
It's over there. Ingo, it's over here. In the middle, you can see.
Yeah, there was also someone there. Oh, then ask your question. If you have the microphone.
Yeah.
Sure. Thank you for a very inspiring talk. One thing that I noticed that was missing from the papers is that is especially important at the time of unprecedented socio-scientific challenges that the world faces, the globe faces, is adequate research on ethical issues, the integration between ethics and science education. And so I wonder what you would say. And this is happening at a time, again, of political extremism or religious extremism, we have a difficult a challenge in our hands.
Yeah, thank you very much. This is a very important area of research. It is actually visible in the science education research literature, but it's not dominating. So that is why you cannot see, but it is evident. There are studies on ethics and those kind of issues. So there are papers published in this area, but the numbers are not high. Yeah. Thank you.
Okay. There's another question from.
Thank you, Professor, for a wonderful, very comprehensive presentation. It gave me a lot to think about. I have two questions. The first is, in your bibliometric analysis, how do you account for researchers who are, say, of Turkish nationality, but are publishing from, say, the University of Oxford? Because then I presume that there are a lot of people who are from global South countries, but are researching in global North countries. And so how does that get tracked into that?
This is basically, the data is based on the addresses that printed on the paper. So the Web of Science is I use the Web of Science data. If you put your address as a Turkey, then it is counted as a Turkish author. I know that there are a lot of Turkish authors are working in abroad, and then including Sibel Erdogan here, so including because they put their address, the international or the country that they work. So they are not included into these numbers. If we include this, I think it will be even much more. But the address is given as Turkey. If you give address as Turkey, then it's counted as a Turkish author.
And
or the first author, actually, or the corresponding author.
Thank you very much. And my second question is more of a comment, but basically in the historical analysis you were providing earlier about the 19th century, the 18th century, I feel like there's a lot of emphasis put on what the global North, what Russia plus the West did. but it wasn't like the rest of the world wasn't thinking. I mean, for example, within the Ottoman Empire, there was Sayyid Nursi, who wrote a lot about science education, and there was Muhammad Iqbal in South Asia. So of course, they weren't publishing in traditional Western style European journals. So what can be done to bring that historical narrative in, so it doesn't feed into this colonial mindset that the rest of the world was quiet while Europe was leading ahead?
Thank you very much for this question. Actually, I considered about this one, whether should I go well beyond the last 200 years or something, like go beyond like 2000 years or 1000 years. You are definitely right. The improvement of the science education, or the education or the science, I shouldn't say science education, but science is, of course, improved initially in the East, not the West, but it is transferred towards the West. There's a lot of work on this one. One of the pioneer researchers in this area who passed away is a Turkish author, Fuat Sezginoğlu. Fuat Sezgin has done a lot of work on this one, how the Muslim world or the East contributed to the development of the science and technology. So you are right, but here, what I'm going to talk, what I talk here, is just basically the science education that we meant today, not in the past. But you are definitely right on this. I mean, it's a long story. If I go back to 1,000 years, everything is changing. You are definitely right on this one. Thank you. Oh, thank you, Ingo. Very nice. Thank you. Thank you very much.
Thank you very much for staying here a few minutes longer. Mustafa, for your talk.